Hi students, how are you? In our previous class, we discussed about refraction of light at curved surfaces. How the refraction takes place at curved surfaces. Now the topic is lenses. You know very well about lenses. Do you know what is lens? Probably you might have observed it in your homes. The spectacles of your parents or your grandparents, they are curved inside or bulged outside. There are so many uses of lenses. First, we have to know what is a lens. Lens should be a transparent material. Light should pass through the glass, that material, and it should refract the light. So lens, transparent material, transparent refractive material. It has curved surfaces, both sides or at least one side. So transparent refractive material bounded by two spherical surfaces or two curved surfaces. Spherical surfaces are at least one surface, at least one spherical surface. So lenses are mainly classified into two types. So lenses are two types, one biconvex lens and biconcave lens. This convex lens also called as converging lens. Converging lens. And this biconcave lens also called as diverging lens. Diverging lens. We know about converging of light rays and diverging of light rays. So lenses are two types, that are one biconvex or converging lens, biconcave or diverging lens. What is the shape of the lens? Let us look about. This is the shape of the biconvex lens. How is this? This is bulged two sides. This curved out, bulged out two sides. Here it is bulged two sides and thicker at the middle. In the middle it is very thick. Edges it is very thin. So it is thicker at the middle. At the edges it is very thin. So the lens which is thick at middle and thin at the edges, that lens is called biconvex lens here. And how is that biconcave lens? Here, this lens is curved insides. This lens is curved insides. How is this? What is the shape of this? It is thin at the edge, at the middle, and thick at the edges. This concave lens is thin at the middle and thicker at the edges. The lens which is thick at the edges and thin at the middle is called here diverging lens or biconcave lens. Again, this lens is divided into, this convex lens is biconvex lens. These converging lenses are, and one side is plane and other side is convex. This is plano convex lens. The converging lenses are two types. Biconvex lens, it is already we have seen. This is one side is plane and other side is curved, other side is bulged outside. So this is at least one curved surface. This has at least one curved surface. This is plano convex lens. And other is what is the shape? Concave. Concavo. Convex. Here this side is curved inside, concave, concavo, it is bulged outside, convex, concavo, convex lens. So these are, how is this? It thin, edges are thin. Okay, here edge is thin, here edge is thin, here edge is thin, here edge is thin. The edges are thin. The converging lenses are biconvex lens, plano convex lens, concavo convex lens. And other, this diverging lens, biconcave lens. This is the biconcave lens. And this is plano concave lens. Concave lens. And other dear students, observe here, this is curved inside both sides, that is biconvex lens. It is one side is plane, so it is plano concave lens. It is curved inside here, so it is, observe, this is convexo concave lens, convexo concave lens. So if you observe this, here it is thick, it is edges are thick. If you observe in diverging lenses, the edges are thick and at middle it is thin, middle it is thin. And this is both sides curved inside, so it is biconcave lens. It is one side curved inside and other side is plane, so plano concave lens. And here it is convex and other side is concave, convexo concave lens. These are diverging lenses. So lenses are two types, one is converging lens, other is diverging lenses. If both sides are bulged outside or thin at edges, thick at middle, that is called biconvex lens. If one side is plane, other side is bulged outside, that is plano convex. If one side is concave, curved inside, and other side is bulged outside, that is called concavo convex lens. As diverging lenses, biconvex lens, biconcave lens, plano concave lens, convexo concave lens. These are the types of lenses. Now terms related to lenses, terms related to lenses. So these lenses are a part of spherical glass. We know very well, in our reflection of light, the mirrors are also made from spherical glass. Like that, this lens is also a part of spherical glass. But in mirrors, they are coated, silvered one side. But in lenses, there is no silvered or coating. So these are made from, suppose here it is, what is this lens? Okay, biconvex lens. Okay, this biconvex lens is a part of sphere. Okay, now we will draw like this. This is a part of the sphere, the first part of the lens, and this is another sphere. It is a part of another sphere. So this sphere has its center. Its center. This sphere has its center. Okay. To convex lens, biconvex lens, it is the first part. Here it is the first part, first curve. So it is the first curve, bulge curve. So this is a radius here. Convex lens, it is a first curved surface. It is the first curved surface. The center of the sphere is center of curvature for this curve. So it is denoted with C1. Next, it is the second surface. It is the second curved surface. To this curved surface, it is the center of curvature. So it is C2. So the convex lens has two curved surfaces. It is C1 and it is C2. And the distance between curved part to the center of curvature is called radius of curvature, R1. This is R2, radius of curvature. We know very well about the middle point of the curved surface is called pole. The distance between pole to center of curvature is called radius of curvature. So this convex lens has two curved surfaces, C1 and C2, two radius of curvatures, R1 and R2. Like that, here again, what is this lens? Good, it is concave lens. So this is the concave lens. It is the part of one sphere like this, and it is another part, another sphere. So it is the first part for the concave lens. So it is the center of the sphere here. So it is the first part here. It is the pole again. The midpoint is called pole. So here it is C1. Why? It is the first part here. It is second part. It is another sphere. It is the second curvature. So the second curve. So this center is called center of curvature. So it is second center of curvature. From pole to center of curvature, R2 here, here R1. Students, carefully observe. For convex lens, it is the first curve. So here it is C1 R1. It is second curve. So here it is C2 R2. For concave lens, it is the first part. So here it is the center of curvature 1, C1 R1. It is second part. Here C2 R2. Don't confuse here. C1 is this side for convex lens. Here it is C1 for this concave lens. So these are made from a spherical glass. One thing you should notice that here two spherical surfaces may equal or may not equal, because it is made from two curved surfaces, two spherical surfaces. So here R1 is equal to R2. This center radius of curvature is may equal to this radius of curvature if both spherical are same. It may be. In sometimes it may not equal the radius of curvature here also. For both lenses, the radius of curvatures may equal or may not equal. That's why we know about r equal to 2f or f is equal to r by 2 in mirrors. The focal length is the twice of the focal length is radius of curvature, or focal length is half in the radius of curvature in mirrors. But in the lenses it may right or may wrong. It may equal or may not equal. If R1 is equal to R2, if radiuses of curvatures are both equal, it is called equiconcave lens. In the case of convex lens, equiconvex lens. If radius of curvatures are both equal. In the case of convex lens, it is called, if R1 is equal to R2, it is equiconvex lens, it is equiconcave lens. If R1 does not equal to R2, in that case, it is simply called biconvex lens. In this case, it is called biconcave lens. Biconcave lens. Okay. In this convex lens, in this lesson we talk about very thin lenses. Very thin lenses. In this case, we take a distance from center of the lens. In lenses, the pole is called optic center. What? Optic center. O. It is called as optic center. Here it is C1. Here it is C2. When the parallel beam of light incident, when a parallel beam of light is, we already read what happens. Here it is air, it entering into the glass. Glass is a denser medium when compared to air. So when it is rarer from denser, what happens? Rarer from denser, what happens? It moves towards the normal. Where is the normal? This is the normal here, the distance between center of curvature. So it bends towards the normal here, and from denser to rarer, what? After refraction like this, two mediums, air to denser, rarer to denser, denser to rarer. Like this, it bends. Like this. Again this. It bends like this, rarer to denser. Rarer to denser, what happens here? Here it is, and it is the center of curvature. So light rarer to denser. Here denser means it moves towards the normal. So it moves toward the normal. Then this is another surface, it moves like this. For this purpose, for this it is center of curvature. It moves next to denser to rarer. Denser to rarer, it moves away from the normal. Normal is here, it moves away from the normal here, like this. So here the light ray moves again, bends here like this. So this is the refraction takes place. This is the refraction takes place. Have you understood? So the refraction takes place rarer to denser, denser to rarer. Here also rarer to denser, denser to rarer. After refraction, the parallel beam of light rays converge at a point. That point is called here focal or focus point. This is F1 here. Here it is F2. This is why the convex lens is also called converging lens. The light rays are converging here, refracted rays. Next, we look. This is biconcave lens. Biconcave lens. The center of the midpoint of lens is called optic center. It is C2 here. It is the first curve, so it is C1. Second curve, it is C2. If a parallel beam of light incident on concave lens, what happens? Let us observe. Here is the first curve. Here, C1. Here it is in air, the light ray, incident ray. It strikes like this. So this is a normal here for this. Light entering from rarer to denser. What happens rarer to denser? It moves towards the normal. So it moves towards the normal like this. So this ray bend like this towards the normal. From second surface, it is here. The light strikes like this. Now it is second curvature. It is optic center. Suppose it is normal now. What happens here? From here it is the denser. It is the denser here. From denser to rarer. What happens denser to rarer? It moves away from the normal like this. It moves away from the normal light and it diverges. We extend back. The diverging light ray should be extended backward. Then it converged, it meet on principal axis. Like this, here also it diverges like this. If you extend the light ray, refracted ray, they meet a point. That point is called focus point or focal point. That point is called focus or focal point. Here it is F1, it is F2. So it is diverging. The incident rays, refracted rays are diverging. So this concave lens is called diverging lens. This convex lens is converging lens. Are you able to understand now why we wrote now convex lens is converging for this reason, concave lens is diverging for this reason, diverging rays. Okay, right. Here C2 has written as 2F2. Here C1 has written as 2F1 also. Here also 2C1, 2F1, C2, 2F2. Rules for drawing ray diagrams. Let us observe. For thin lenses, this convex lens is shown like it is bulging outside, thicker. So this is represents as like this. This convex lens, for our convenience, is represented as arrow mark like this for very thin lenses. And this concave lens is represented as like this. How is this? Means thicker at edges, thin at middle. It is thin at edges, thicker at middle. It like this. So thin lenses represented as convex lens like this and concave lens like this. Further in our all diagrams we represent concave lens from this symbol, we represent convex lens this by this symbol. We represent concave lens by this symbol. So rules for drawing ray diagrams. Suppose on convex lens, first rule, this is a convex lens. Here it is C1, it is F1, it is F2, C2. Here, if a parallel light ray incident on convex lens, just now we have seen what happens after refraction. It go through the focus. If a parallel light ray incident on convex lens, it goes through the focus. Next, the second one, the middle is the optic center. It is optic center C1 F1, C2 F2. If a light ray incident through the focus, after refraction, it become parallel to the principal axis like this. Are you recalling something? In our mirrors, reflection of light, as this parallel light ray moves through the focus, but in lenses light goes refract other side also. So the parallel light ray after refraction go through the focus. The incident ray which incident through the focus after refraction, it will become to the parallel to the principal axis. Third rule is here F2, C2, F1, C1. If a light ray that passes through the optic center, do not deviate, it go on the same path. And also a light ray which passes through the principal axis nothing but it is the center of curvature. It is also a normal, so it also goes through the same path. So the light ray which is passing through the optic center will not deviate, do not deviate, it goes same path, it refracts. And also the light ray which is passes through the principal axis also do not deviate. The parallel light ray through the focus, the light ray which is incident through the focus become to parallel the principal axis. The ray which is incident through the optic center, it will not deviate. Okay. Now let us observe on concave lens. Concave lens. Here it is the concave lens. In concave lens, it is the first curved surface. So here is the C1, here is the F1, here is the C2, it is F2. If a parallel light ray incident on concave lens, what happens? We have seen just now, it diverges. It diverging like this. Okay. How it is diverging? If we extend it backward, it meets at focus. So it is appear to diverge as going through the focus. It is the first case. In second case, this symbolic representation of It is optic center F2 C2 F1 C1. So when a light ray incident through the focus, it appears to through the focus, appears to incident and go through the focus. Here it is appear to incident through the focus. After refraction, it diverges like this. It will become parallel to the principal axis. Parallel to the principal axis ray diverges. It is appearing as focus. The ray which is appearing incident through the focus, it will diverge, become to the parallel to the principal axis. Next, third case. A ray which is passing through the focus point, optic center. A light ray which is incident through the optic center do not deviate, it go in the same path. Also a light ray which is incident through the principal axis will not deviate. Okay, these are the light rays, behavior of light rays on concave lens. It will help us draw the image positions for various object distances. To find out various image positions to various object position by formula, we have one formula. I forgot to tell you now. The formula is N2 by V minus N1 by U is equal to N2 minus N1 by R. You know, V means image distance, U means object distance, R radius of curvatures. Here N2, N1 or N2 are refractive indices. Here both mediums are there, rarer and denser. So the refractive indices of both medium N1, N2. These N1, N2 are refractive indices. Here 2 means indices. Now V means here U object distance, V means image distance. So this formula will help us to find out the distances between. For plane mirror we can use this formula for plane mirrors, for plane surfaces. For plane surfaces, this radius is infinity. So N2 by V minus N1 by U is equal to N2 minus N1 by infinity. This 1 by infinity become 0. 1 by infinity becomes 0. So N2 by V minus N1 by U is equal to N2 minus N1 by infinity. This become 0. So if we bring that side, N2 by V is equal to N1 by U. N2 by V is equal to N1 by U, object distance. It is for plane surfaces. It is for curved surfaces.